Hello everyone, welcome to today's class. In this lecture, we are going to continue with our topic of integration and we'll be moving forward to the topic of trigonometric integration. So basically, we'll be dealing with all the trigonometric terms, though we have seen few of them in basic integration also. But this time it is going to be very specific with the use of properties of trigo. Okay, and the terms specifically designed to use the manipulation of trigo. Okay, so let's start with the first form. So we'll talk about I try to break this down into forms so that it's easier to recognize, because see, every question will have a unique approach and sometimes it's very tempting to see all the kinds of variations. Okay, in basics also we saw a lot of variations. So I'll categorize the trigonometric integration in certain forms, which will help you to summarize this simply. So the first form is integration of sine raised to power mx or cos raised to power mx. So you will have only single power of sine and cos that will be less than equal to 4, not more than 4. Okay, I mean, we can do that for more than 4, but it will be very lengthy, so not even relevant from examination point of view. So let's see how will we integrate cos square sine square first. So see, cos squares cannot be integrated directly. There is no formula directly for integration of cos square, integration of sine square. I cannot say that the integration of cos square is sine square x. No, I cannot say that, because the rule is only integration of cos x is sine x. Okay, so if only the problem is that this square, sine square or cos square, we cannot deal with this directly. Okay, so somehow the idea is to remove the square, and in order to remove the square, what is the property we are going to use? The same trigonometric property that we used earlier, 1 plus cos 2x. I told you that this property was very much relevant. Okay, so you'll see the application part now. 1 plus cos 2x by 2, 1 minus cos 2x by 2. You know what is 1 plus cos? That is 2 cos square, half of angle. So just I have replaced that 2 on the left side and taken it into the denominator. That's it. So even if you don't, if you have learned this property as 1 plus cos 2x, which I do prefer, so use like that only. Okay, so what you have done, the 2 here, we have taken this in the denominator. That's it. Okay, all right. So 1 plus cos 2x by 2 is cos square x, 1 minus cos 2x by 2 is sine square x. The idea is to remove the square, and once the square is removed, I can integrate 1, I can integrate cos. That's the whole idea. Let's see the question. So sine square 2x. Now instead of x you have 2x. So we'll use the same property, 1 minus cos of double angle. What is the double angle? Of 2x, 4x upon 2 integration dx. What, I'll keep 1 by 2 outside. What is the integration of 1? That's x. What is the integration of cos 4x? That's sine 4x dx. Sorry, integration is done now. But one casual mistake is that the coefficient of x is 4. So that 4 will come in the denominator. Okay, so remember, ax plus b is still applicable here. Okay, next, same thing we'll do with cos square. So I can write cos square as 1 plus cos of double angle. Now what is double of 3x? 6x divided by 2 integration dx, and rest steps are same. 1 by 2 outside, integration of 1 is x, cos 6x integration sine 6x, but divided by 6 plus c. Okay, so remember, squares and cubes directly cannot be integrated. We have to break it down to simple sine and cos, and for that we are using property of double angles. Okay, let's look at this. What if they are both combined? The idea is still not new. This is still pretty much the same. It's just that I'm going to introduce few steps, and rest all the steps will be same. Okay, so sine x cos x, I can rewrite this as sine x cos x whole square. Integration sin x cos x whole square dx. Now what I'll do, I'll multiply by 2 and I divide by 2. Why? Because 2 sine x cos x is what? This is integration sine 2x by, sine square. This is sine 2x and there is a square present on it. Okay. And that is completely inside the bracket. So basically it becomes sine 2x whole square and denominator is 4 dx. So take 1 by 4 outside. What is the integration of now sine square 2x? So you have to repeat the same steps of question number 1. So integrate it, 1 minus cos of double angle by 2 dx. Okay. And now I'll take this 2 and 4, combine it, 1 by 8, and integration of 1, again same, x, integration of cos 4x is sine 4x upon 4 plus c. That's the answer. Okay. So if sine square is there, you can integrate 1 plus cos 1 minus cos properties. Cos square, same thing. Sine square, cos square combined. So just combine it using this property. Okay. 2 sine x cos x is sine 2x. So what I've used is again property of trigo, 2 sine x cos x. While learning the property, learn forward as well as learn backward, because you never know which one you might require to use. Okay. All right. Now how to integrate sine cube cos cube, and then we'll go to the power of 4 also. But let's see power 3. Power 3 has a unique idea. The idea is, where have you seen cube in any identity of trigo? Where have you seen cube? You have seen sine 3x. What is sine 3x? 3 sine x minus 4 sine cube x. If I try to generate sine cube separately, I'll take this here, I'll take this here. So 4 sine cube x is 3 sine x minus sine 3x upon, and this take this 4 on the other side, this becomes 4. So you can rewrite this sine cube as sine 3 sine x minus sine 3x by 4. Now if you want, you can learn this. If you want, you can generate this. It's your call. I'm leaving that choice to you. You decide which one do you like better. Learning the property, I've given the formula sine cube x, learn this. Cos cube x, learn this. Otherwise, try to generate it. Okay. I've shown both ways. Now I'll just put the results in this. Same with the cos 3x now. So same thing with the cos 3x also. You learn the result of cos cube and then that. So this is 3 sine x minus sine 3x upon 4, and then you have to integrate. So 1 by 4. What is the integration of 3 sine x? That's 3 minus 3 cos x, and this negative will become positive because of the integration. Sine 3x integration is cos 3x with negative upon 4. 3. This is coefficient of x plus c, ax plus b format. Okay. Same with cos cube x. If you try to generate, it will come integration 3 cos x, instead of minus there is plus. Okay. Plus cos 3x by 4. So 1 by 4 again outside. Cos integration is sine. So 3 sine x plus cos 3x integration is sine 3x upon 3 plus c. Okay. All right. I'll introduce one question here. Remember we just combined sine square cos square. Now we can combine sine cube and cos cube also. What if this is a question? You'll use always the same idea, just combine. Both have the same power, now combine them. How will you combine this? Integration sin x cos x whole cube, then you multiply by 2, divide by 2. What is 2 sin x cos x? That's integration of sine 2x. I'll put it here, I think, rather writing like this now. This will be slightly lengthy to solve, I think. Let me cut some space. So this is integration sine 2x whole cube, so sine cube, and 2 is inside the bracket, so 2 cube 8, okay, dx. Take 1 by 8 outside, and now this is a straightforward question. Sine cube 2x, how do you integrate cube? So for that, you remember the property that we discussed, okay, that in order to do the integration of cube, you have to remove the cube and you use it using the identity of sine 3x. So 1 by 8, if I use the same kind of result, it will be 3 sine, instead of x, 2x is used. So every time we are writing x, I'll write double of it. So 2x minus then sine 3x, but here x itself is 2x. So 3 times of the angle basically, okay. 3 sine of the angle minus sine of triple angle. Triple angle is 6x by 4. This is the integration that we have to do. So I'll write it here now. So this will become 1 by 8, final answer effectively. 3, sorry, I can combine this now, 8 and 4, 32. Now that's right. Integration of 3 sine 2x integration is minus cos 2x and then coefficient of x, and again negative cos 6x with another negative becomes positive upon 6 plus c. Okay. So minus 3 by 2 cos 2x plus 1 by 6 cos 6x plus c. 1 by 32 is outside. This is your answer. Okay. So you can always generate new questions easily in integration. Okay. So remember, try to understand integration rather than learning just straightforward formats. Okay, you have to see what you can integrate. You should remember only that I can integrate cube. That's it. If you can integrate cube of sine and cos, rest manipulation you should be able to do, because the moment you see cube, you should know, yes, this is integrable. We can proceed forward. Okay. All right, let's move to the even higher power. Let's take sine 4x. Okay, right now we are discussing only the first form. No? First form is only dealing with sine or cos single powers till 4. So sine 4, what I can do, I can write this as, this is sine square x whole square. Now why I have written sine square? Because I know I can integrate sine square. How do we integrate? We write this as 1 minus cos of double angle by 2, but there is a whole square in it. The problem is this whole square. Without this I could have done this, but with this I cannot proceed further. So I'll open it. 1 by 2 square is becoming 4, so I'm writing 1 by 4 outside. 1 square plus cos square minus 2 cos x dx. If you look at this expression, you'll say I can integrate 1. I can integrate this. This is actually cos. This is cos 2x. Okay. So you'll say that yes, I can integrate the first expression, third, and you should say yes. Now I know that I can vary it slightly, cos square, because of the power 2, and still I can integrate this. Let's integrate. 1 by 4, integration of 1 can be done. Cos square can be rewritten as 1 plus cos of double of this angle, 4x by 2 minus 2 cos 2x dx. And now integrate 1 by 4. Let's take one more step, integration. Add this 1 and 1 by 2, na? So it becomes 3 by 2 plus cos 4x by 2 minus 2 cos 2x dx. So this becomes 1 by 4. Integration of 3 by 2 is 3 by 2x plus cos 4x integration is sine 4x by 4. Already 2 is here, so 8 minus this is 2 sine 2x by 2 plus c. Okay. All right, we're done with this. So for practice, you can take this as a question, cos 4x. Okay, I'm not going to discuss this. Even you can try this question also now. Now that I've already discussed how to integrate sine square, cos square, sine cube, cos cube, you can try this also, cos 4x, sine 4x. Okay, you can practice this also. First you have to combine sine and cos, then I've taught you how to deal with power 4, square square. Okay, all right, that covers your first form. Let's move to the next one. The next one is basically in the product form. Okay, this is in product form, sine sine, sine cos, cos cos. Okay, basically. Now the problem is that yes, there is sort of product rule, but I told you that's called by parts, and that should be your last resort to solve any problem, not the first choice. So the problem is here that they are in multiplication. What if there was a plus sign in between? We could have splitted the integration in two parts and be done with this. So the idea is to convert product to sum or difference. Okay, in order to do that, there is a property in Trigo, if you can recall, that's 2 sine a cos b, that is sine a plus b plus sine a minus b. Similarly, 2 cos a cos b is cos a minus b plus cos a plus b. 2 sine a sine b is cos a minus b minus cos a plus b. We'll use this to break the product into addition or subtraction, and once it's done, I think we can integrate a single sine or single cos. So let's see a few questions now. Let's keep the formulas on screen so you can always have the look. Okay, first question. This is integration of sine 4x sine 3x. No? So first thing, the formula needs 2 in multiplication of the product. So let's multiply by 2. So adjust it by 1 by 2. So this becomes integration of 1 by 2. Now 2 sine a cos b, this is your a, that's your b. What is 2 sine a cos b? Sine of a plus b, add them, 7x plus sine of a minus b, subtract them, sine x dx. Just one step question. After this 1 by 2, what is the integration of sine? Minus cos 7x by 7 plus, not plus, minus cos x plus c. As simple as that. The only problem was to convert product to sum. Same thing you can do with this also. A, b, sine a, sine b, but we need 2. So multiply by 2 divided by 2. Now this integration will look like 1 by 2 integration. What is 2 sine a sine b? It's on the screen. Cos a minus b minus cos a plus b. Cos a minus b. So 3 minus 2 is x minus cos a plus b is 5x dx. So the answer is 1 by 2 integration of cos sine x minus sine 5x by 5 plus c. Okay. All right. Let's look at the next question. Same thing. One second. Is equal to, same thing we'll do, multiply by 2 divided by 2. This is cos a cos b. What is cos a cos b? 1 by 2 cos of a minus b. Now the problem is when you subtract 2x and 4x, what do you get? 2x minus 4x is minus 2x, though you should get minus 2x. Okay, let's write it for the time being, and then plus cos a plus b, that's cos 6x. This addition is not a problem, but because of this negative sign, cos of minus theta as such is same as cos theta, so we can remove this cos. The negative inside the cos can be directly removed, okay, using the property of trigo again. Cos of minus theta is cos theta. So this dx, and there is an integration ongoing, so let's integrate now. 1 by 2, this will be sine 2x by 2 plus sine 6x by 6. Coefficient of x, coefficient of x. Do not forget ax plus b format. Very crucial. Okay. Now, this concept cannot be restricted only to the multiplication of 2. This can be further extended to the multiplication of 3 cos terms or 3 sine terms or their combinations also. The idea is still the same. You use the properties. So let's take these two terms, multiply by 2, divided by 2. So this is 1 by 2 integration 2 cos a cos b, same thing, same as the above question. Interesting. So cos, I'll copy it, cos 2x plus cos 6x, but they are still in multiplication with cos 6x dx. Fine. Let's solve it further. Let's literally multiply this, cos 2x cos 6x plus cos square 6x dx. Okay. This is again the same format, 2 cos a cos b. So what do we need? Multiply by 2, divide by 2. And this is what? Square. How do we solve the squares? Integration of cos square sine square. 1 plus cos of double angle. So use this idea now. Okay. So 1 by 2. This is integration of 2 cos a cos b. So cos a minus b. So again, one thing I told you that you have to do like 2x minus 6x na, a minus b. Or what you can do is you can take this as a and this as b. There is no constraint that the first angle has to be a, second one has to be b. No, you can call anything. They are in multiplication. Na? A b b a, same thing. So cos a minus b. So cos directly 4x plus cos a plus b, cos 10x by 2 plus this will become 1 plus cos of double angle 12x 6x double by 2 dx. Now let's integrate. Denominator 2 I am taking outside, so 1 by 4. Integration of cos is sine 4x by 4 sine 10x by 10 plus 1 integration is x plus sine 12x by 12 plus c. Okay. 10, 8. All right. I'm giving you one more question. That's for your practice, because the same idea can be applied on sine also. So I'm giving you a simple one, sine x, sine 2x, sine 3x. This is for your own practice. Same idea. Try to do this, okay, on your own. Now, there are certain questions in integration that are very, very unique. Okay, and this is one particular question that's very unique. Reason being, it's not really a question of integration. This is really a question of your trigonometric identity. Okay, and problem is this is not something standard identity. You don't learn this as an identity. But point is, this is some to prove question of trigo. Okay, class in 11th trigo. Now that to prove result, I'll tell you what the result was and we'll generate that. The point is tan 3x, tan 2x, tan x is actually tan 3x minus tan 2x minus tan x. This is true. Point is we can break only this multiplication, not for any other. Only for this integration or tan 3x, tan 2x, tan x, we can break this multiplication to this tan 3x minus tan 2x minus tan x. And if we can break, I think the integration part will be very simple. So those who might be thinking like how we are going to prove it. Yes, we can generate this result. Let's generate it. Tan 3x can be rewritten as tan 2x plus x. Okay. So this is tan 3x is equal to, use a plus b property. So tan a plus tan b upon 1 minus tan a tan b. Okay. What I've used is tan a plus b form property. So 1 tan 2x tan x upon tan 2x tan x, and then cross multiply. So you'll get tan 3x minus tan 3x tan 2x tan x is equal to tan 2x plus tan x. Take these terms over here, take this product, take this whole term over here, interchange the position. So what do we get? Tan 3x is equal to, tan 3x minus tan 2x minus tan x is equal to tan 3x tan 2x tan x. Okay. So we have proved it now that this product can be actually written as integration of tan 3x minus tan 2x minus tan x. And if we can write this, I think the integration is very simple now. Integrate all three terms. What is the integration of tan? That's log, negative of log mod cos 3x. But remember, coefficient of x by 3 minus log cos mod inside 2x, okay, by 2 minus log cos mod cos x plus c. Okay. All right. Fine. So yes, very unique, very weird kind of a question, but there is no manipulation in this. There will be direct questions like this, and one is, if you ever see like this expression, now at least you know that something like this exists, because if you are looking for this question in the first time, you'll not have any idea how to go about this. Okay, so this is the property. This is not exactly a property, this was a question actually we did in Trigo. So we have used that question, but that's a very interesting result, that the product is somehow directly broken in this, but this combination exists for only 3x 2x x, or double of it, 6x 4x plus 2x, right? Like that. Okay. All right, that covers your second form. Let's move to the third one. The third form deals with integration of tan and secant multiplication, but the important part is that the power of sec should be even, and then we'll use the idea. Same with cot, cosec also. If something is working with tan and sec, same thing will work with cot and cosec also. Same idea, still even power. Okay. What is the hint to solve these questions? Just put tan x as t. Okay. Rest manipulation, how it's done, we'll see in the question. But you look at the form and you should know if sec power is even or cosec power is even. What do? You put tan x as t. Let's see. So I'll start from here, same thing. Let tan x is t. You'll say yes, sec square x dx is dt, but there is no sec square, there is sec raised to power 4. So fine, more power is there, not less. So what you do is you generate tan, let's rewrite this, tan square x Then sec power 4, I can rewrite this as sec square x in multiplication, then dx. This sec square x dx become dt. Okay, so fine. This tan square actually become t square. This becomes dt. What about this? So what do we know about sec square x? We know it's 1 plus tan square x, means 1 plus t square. Okay. All right. So let's write down. Now multiply. Integration t square t raised to power 4 dt. Now I think after that this integration is very simple. T cube by 3 t raised to power 5 by 5 plus c. Okay, and you can replace the value of t. What was t? Tan x. So tan cube x by 3 plus tan raised to power 5x by 5 plus c. That's the answer. Okay. This is how you are going to do. You require, if you take tan x as t, you need sec square x. So in order to get the sec square x, separate the sec square part and remaining part can be reconstructed in the form of 1 plus tan square or 1 plus t square accordingly. Let's look another variation. This time only sec power 4 is given. There is no tan present as such. So still I am going to use the same idea. First I am going to write this as sec square x into sec square x, and then I am going to use and dx. Why I am going to do this? Because I learned this, that now even power of sec and cosec I have to put tan x as t. So that's why I need sec square x separately. So let tan x equal to t sec square x dx is dt, differentiating it. Now this thing is present already, so I'll put at d as dt. But what about this sec square? I can again write sec square x as 1 plus tan square x. So 1 plus basically t square. We can integrate this. This is integration t plus t cube by 3 plus c. That's tan x plus tan cube x by 3 plus c. That's the answer. Okay. All right. Same thing can be done regarding cot and cosec also. Let's solve. Pretty much exactly same. Okay. Sorry, pretty much the same. Cot na. So this time for this, what you have to take as t? For this you have to put tan x as t. For this put cos x as t. Sorry, cot x, not cos. Cot x as t. Rest you can do accordingly. Fine, let's, because cot x differentiation is minus cos x square, so I am going to separate it first. Okay, so integration cot, 1 second, integration, this is cot na, so integration cot is, let it be as it is, but we need cosec square x dx. Okay, and let cot x as t minus cosec square x dx as dt. There's no negative present here. Okay, there's no negative present here. So what we'll do is we'll put a negative and put a negative here to adjust. So now this whole thing is your dt, rest minus integration cot is t, cosec square is also 1 plus cot square, so 1 plus t square again dt. So you'll see again pretty much the same expression, t square plus t raised to power 4 dt with a negative sign. That's the only difference. So this is t cube by 3 plus t raised to power 5 by 5, okay, plus c. What is our t? Cot cube x by 3 plus cot raised to power 5 x by 5 plus c. Okay. So one single format working for tan as well as cot, not a problem. All right. Now cosec square. This is pretty much same as sec raised to power 4. Okay, cosec power 4x. So giving you this also as a practice. Do same as sec raised to power 4x integration. Just that you'll change this to cosec square and 1 plus cot square property. That's it. Okay, next one, fourth form. Now this time you have tan and sec in product, but both of them has the odd power. Okay, so if they have the odd power, what do? You're going to put sec x as t. That's it. That's only you need to remember. This is pretty much understandable. Okay, so what is the differentiation of sec x? That's sec x tan x. So I will separate sec x tan x out of this. So integration, I'll write tan square x sec square x because I need one tan x sec x here. So tan x sec x dx. Okay, so let's see how this is helping this whole thing. So first let sec x as t, so sec x tan x dx is dt. That's present here. That's why I was focusing that get one power of tan and one power of sec separate, so because they will be combined with dx and that becomes dt. Okay, now the question is integration of this part becomes dt. Sec square is nothing but t square, but what about tan square? So still use the same property, 1 plus tan square x is sec square x. So basically tan square is sec square x minus 1. Put it in there. Sec square minus 1 means t square minus 1. Okay, so now integrate, multiply this, t raised to power 4 t square dt. So this is t raised to power 5 by 5 minus t raised to power 3 by 3 plus c. So this makes it sec raised to power 5 x by 5 minus sec raised to power 3 x by 3 plus c. Okay, all right. Next form is just power of tan or power of cot. Okay. Now for that, as such, I'm not giving you any hint or something. It depends from question to question, but the idea you should see this time, that how you're going to manipulate this. Let's see. First of all, cube directly cannot be integrated. So I'm writing this as tan square x into tan x. You might think why? Because there is an identity of square at least. 1 plus tan square x is sec square x. If I generate tan from it, what do we get? Sec square x minus 1 into tan x dx. Okay. Multiply this. So sec square x into tan x I'll write tan x first. You'll see why. So in product, whichever one I want, I can write first. So I'm writing tan x first. Minus tan x, okay, dx. Now this is a good thing. Why? Tan x integration, we know this is a standard result. We can integrate. Now for this part, what we can do is, for that to understand, I'll break this into two integrations. Though we have not done this, mostly we did it in one single integration, but I'm breaking down this in two integrations. So this one we already know, no problem. For this integration, what we do, we take tan x as t is your sec squared dx dx, your dt. If you differentiate tan x, what's the differentiation? Sec square, and then dx comes with it, that becomes your dt. So this will work now. So this becomes integration t dt minus integration of tan x is minus another minus, so that makes it plus log mod cos x plus c. What is the integration of t? T square by 2 plus log mod cos x plus c. Put the value of t. T was tan x. So tan square x by 2 plus log mod cos x plus c. So idea was to get even power out of it, and then writing that as sec square minus 1 and then multiplying it, and then automatically we got two separate questions which we were able to integrate. Same thing can be done for power 4 also. What I'm going to do is I'm going to write this as tan square x into tan square x. I'll just remember the same steps. What we do with this after this? We wrote this as sec square x minus 1. This one, keep it as it is. Though you can convert this, but there is no point in doing that. Now, multiply. Okay. Dx, dx. So if we multiply, what do we get? Tan square x sec square x dx minus another tan square x. So we'll integrate in two parts. This one, tan, we can integrate. Tan square is not integrable. Fine, we'll think about that. But at least we know, na, if we take, again, we'll take the same thing. Let tan x is t. So sec square dx is your dt. So this becomes integration t square dt. After that, you know you can do this. How can we integrate tan square? We cannot integrate tan square. So come to the basics. This was already discussed in the questions of basic integration, that you convert this into something which can be integrated. It can be written as sec square x minus 1. Again, the property, and you can integrate sec square, you can integrate 1 also. So this becomes integration of t square is t cube by 3. So tan cube x by 3. Okay. Minus integration of sec square is tan x minus x plus c. That's your answer. Okay. Tan raised to power 4. If you want, you can open this bracket. That's it. Same thing can be done regarding the cot also. Okay. Cot cube also, cot square also. Practice this. Same idea, nothing different. Write this one as cot square into cot. This is cot square into cot. Then replace one cot square here with 1 plus cosec square and do the same steps. Automatically things will happen. Okay, next form. The next form deals with the sine and cos with certain powers on it. Okay, 1, 2, 3 like that. Okay. Now there are as such 4 cases. Mostly 3 cases are the easier ones. The 4th one is slightly lengthy. though we have done few part of it. The point is, sine power will be something, cos power will be something. They should not be same. It's not a necessary condition as such. They may or may not be same. The idea is that if the power of sin x is odd, you put cos x as t. If the power of cos x is odd, you put sin x as t. Means whichever is the odd power, you put the opposite one as t. If both are odd, literally you can put sin x also as t, cos x also as t. Your call. Okay. But what if both power are even? You cannot do this simply with a substitution. Okay. Then for that, what do you have to do? You have to use the property of 1 plus cos, 1 minus cos to remove even powers. Okay. If both are even, so you have to use this property. Anyway, let's look at the first question and try to understand. Okay, for this, who has the odd power? Sine has the odd power. If sine has the odd power, we'll take, let cos x as t. If cos x is t, then minus sine x dx is dt. Okay. So minus sine x. There is no minus sine x present here. Sine x itself is not present. Sine cube is present. So we'll generate this. So I'm rewriting again this as sine square into sine x. So it is sine cube x dx. Then I'm writing cos 4x. Okay. Same question in product form. Just broken down the sine cube as sine square into sine. So that sine x dx is there. But you need also a negative sign. So put a negative, adjust it. Now negative of integration. This is first of all this sine x dx. That's your dt. Cos is t, so t raised to power 4. What about sine square? So use the property sine square is 1 minus cos square, 1 minus t square. Simple enough. If somebody is wondering what happened, this is what really happened. I've generated sine square as 1 minus cos square using that. Negative is there, na? So let's multiply this negative. If we want, we can multiply this with this also, and we have to multiply by t raised to power 4 also. So this becomes t raised to power 6 minus t raised to power 4 dt. I have taken negative also inside now. Okay. If you want, you can skip that. T raised to power 7 by 7 minus t raised to power 5 by 5 dt. Okay. So what was our t? T was cos. So cos raised to power 7x by 7 minus cos raised to power 5x by 5 plus c. I think I've written here wrong, dt. That was plus c. Okay. That's the idea. Next question. Let's see. This time, which one has the odd power? Cos. If cos has the odd power, let sin x as t, then cos x dx is dt. We need cos separately. So let's generate cos sin square x. This is cos raised to power 4x into cos x dx. Okay. Even write this power 4 as cos square x whole square. Okay. Now same thing, cos x dx is dt. So I'm writing this as dt. Sin x is t, so t square. Now what is cos square? 1 minus sin square, means 1 minus t square, but there is a whole square on it. Okay. So now literally multiply and open the whole square. 1 plus t raised to power 4 minus 2t square dt. So this becomes integration t raised to power 2 plus t raised to power 6 minus 2t raised to power 4 dt. So t cube by 3, t raised to power 7 by 7, 2t by 5 plus c. So this is t was sine, na? So sine cube x by 3 sine x raised to power 7 by 7 minus 2 sine x raised to power 5 upon 5 plus c, of course. This is the benefit of learning the formats. You cannot recall so many questions, but you can recall formats. Both odd. What I told you, if both are odd, take anything as sine, take anything as t. I prefer sine x as t. You are taught also sine first, then you are taught cos. So take sine as t. Because the reason I'm taking this, because it doesn't generate negative sign, so we don't have to worry about that. So cos x dx is dt. So you need a cos with dx. So generate it. This is sine cube x. This is again cos 4, which will be written as cos square whole square into cos x dx. Then do the substitution. This as dt. This becomes dt. Sine is t cube. Cos square is 1 minus sine square, and that means 1 minus t square whole square. So same thing, just now t cube is there. 1 plus t raised to power 4 minus 2t square, a minus b whole square. I'm not going to explain that. This is integration t cube plus t raised to power 7, even higher, minus 2t raised to power 5 dt. So t raised to power 4 by 4, t raised to power 8 by 8 minus 2t raised to power 6 by 6 plus c. So okay, so sine, we have taken sine x as na, still same thing now, sine x by 4 sine power 8 x by 8 minus 2 by 6. 2 by 6 can be rewritten as minus 1 by 3 sine x raised to power 6 plus c. Okay. Somebody integrate this with cos, you will get the result also in cos. And don't worry, yes, your answer will be different than the sine one. It's because the answer of integrations are never unique. The answer of integration depends on the style of integration. The style here is we are using sin x as t. If somebody uses cos x as t, he has a different style. So different style will result in the different answer. Okay. All right. That pretty much covers all the forms. Okay. More trigo. Mostly all the forms. There are certain more also, but I think that pretty much covers your basics of trigonometric integration. Now one particular kind of question, that is this one. Again, very unique kind of question, not because a very unique property is used, a very unique style of adjustment is used in this question. So let's see this. You have this, the idea is to how to identify this kind of question is cos is in product. But the problem is they are in denominator. This question can be written as 1 by suppose sine x minus a, sine x minus b. Still you can use the same idea. Or the question can be like one is sine, another one is cos. Okay. So as such we are going to do only one question, but effectively see these are the possible questions that can be created out of this same idea. Let's see how to approach this. The first two steps are the crucial one and the most weirdest one, because you will ask, how will we know? You cannot know this. You learn this, you see this, and then you apply it in on the next question like this. Okay. So the first step is cos x minus a x minus b. I'm not doing anything with this because it's not going to do literally anything. Somebody is thinking I multiply this by 2 and then use property of 2 cos a cos b. Fine, you can do that, but you generate product to sum or difference in the denominator. You cannot split integration in denominator. So even that idea won't even work here. So let's generate. I'm putting sine, multiplying this with you can take a minus b or b minus a, your call. So I'm taking in order sine a minus b. Okay, let's take a minus b. Now that I have forcibly multiplied, I have to adjust it. So I'll divide also by sine a minus b. Okay, that's your first step. So now what you do is, after doing this, you add x and you subtract x. Okay, first of all we generated sine a minus b. The second step is add x and subtract x in this expression inside sine. Now what does that do? That makes it look like x plus a minus x minus, sorry, okay, I don't want plus because x minus a is there, na? So try to generate the same thing. I think x minus b is there, so let's write x minus b first, and minus x plus a is there, so take negative out of it. That makes it x minus a. Try to see if we still have the same thing. Okay, open the bracket and see if we still have the same thing. What I've done is I've combined this x with this, I've combined this x with this. Okay, and then slightly readjusted by taking negative common. So far with me? The most important step of adjustment is this one. Okay, that was the question. Now use the property of sine a minus b. What is the property of sine a minus b? This is following 1 upon sine a minus b. Now it's going to take a long time now. So let's copy it. Integration, this is sine a, so sine a cos b is x minus a, minus cos a sine b is x minus a. Denominator I'm splitting it, x minus a, x minus b. Here the also denominator cos x minus a cos x minus b. Now cancel cos x minus a, cos x minus a, cos x minus b, cos x minus b. What do we get? Copy this. Sine by cos, that's tan x minus b minus tan x minus a. And we are done because we know we can integrate tan. So what is integration of tan? Minus log mod cos x minus b. Okay. And this is another negative, negative of negative, positive log mod cos x minus a plus c. Okay. So basically your final answer 1 upon sine a minus b. This is log a minus log b, so you can combine this into a single log mod cos x minus a upon cos x minus b plus c. Okay, so yes, very weird kind of adjustment, but that's it. I'll repeat the key steps. You multiply this with, first of all, sine a minus b in the numerator, then adjust in the denominator sine a minus b, then forcibly add x and subtract x to make the expression still the same. Combine minus b with x, so that is x minus b. Combine minus x with a, but take negative common, it becomes x minus a. Open the property of a minus b, cancel it, automatically the integration will happen. Only you need to know the first two steps. Okay. If you can write these two key steps for the other variations that I have mentioned, you can solve any question. There will not be a problem. Okay. All right. I think that's it for this trigonometric integration. We have covered a lot of questions, lot of forms. Okay. Again, don't try to learn each and every question rather than learn the process. Okay, just and for the short notes, make these make a table of these forms that I've mentioned. Okay, I've given the examples. You make a short note of this. It'll be much more simpler to revise. That's it for this class. See you in the next lecture. Good day, everyone. Bye.